basically to code. I think so the code runs, but I don't know. I'm not so sure. This is the code, but we'll look into it later. Right now, let's watch this video.
Hi, I'm Jonathan Engelsma. In this screencast, we're going to take a look at Lex.
I have 2x the speed so that you can do it faster. You can put it into 0.5 and you will hear the proper thing.
In particular, we're going to give you a brief introduction to lexical analysis. We're going to talk about what Lex exactly is. We'll talk about how it works and give you some examples, and then we'll wrap up by a little hands-on demo of a sample program we're writing that utilizes Lex. So in order to understand Lex, we need to take a look at the larger language processing stack of the typical compiler out there today. So we start out with a source file or a character stream, and we feed this into the front end or the first phase of compilation, which is known as lexical analysis. Sometimes we call this modular software a scanner or a tokenizer, but it generates a stream of tokens, and tokens are groups of characters that mean certain things in whatever target language we're trying to, or whatever source language we're trying to compile. And we take that token.
So we just need this much language for Lex analysis. Then there is Yak and stuff, but we just need Lex. So we'll just be looking at this. So let's just go to
compiler, and it's this very first phase that we're going to be looking at in the remainder of the screencast. So we're looking at lexical analysis, or the scanner part of our compiler. So lexical analysis, just to make it a little bit more clear, takes the source code. So up in the upper left, you see a very simple swap function written in the C language, and it consists of various tokens that are valid in the C language. So our scanner is going to take that input source and produce a stream of tokens, as we see depicted here. So the very first token in the file is the keyword void, followed by the identifier swap, which is something the programmer introduced. It's the name of a function, followed by a left parent, all the way to the final closing right brace. And of course, it's this token stream that we feed into the parser to do syntactical analysis and to ultimately build our parse tree. So what is Lex? Lex is a scanner generator. So instead of writing a scanner by hand, which is not that difficult to do for very, very small languages, but could become very complicated if we have a larger set of tokens. So Lex will allow us to describe a set of regular expressions, and with each of those regular expressions, we can associate an action. And these actions are going to be written in the C programming language. When we run Lex on this input file, which lists out these regular expressions and their associated actions, Lex will generate a table-driven scanner, and it will place that code in a file called lex.yy.c by default. Now, Lex is the original Unix Lex utility, and it's been implemented in the open source in a program known as Flex. So when you hear people talking about Lex and Flex, they're essentially talking about this same utility. So Lex input is fairly straightforward. We basically are going to have a text file, a source file, with 3 parts to it. The very first part is optional, and it can contain lines that control dimensions of the tables that are generated internal to Lex. It can contain definitions for text replacements. It can contain global C code that is going to be utilized by the actions. And there's a special syntax for including C code in that first part. And we'll take a look at that later in our hands-on example. We terminate this first part with the token %%. So the %% token up there separates the first part from the second part. And the second part is where we list out our regular expressions. So we're going to have a regular expression pattern, then some white space, and then an action. And the actions are going to be C code. It could be a single C statement, separated or terminated with a semicolon, or it could be a code block where we have a left brace followed by one or more valid C statements and a close right curly. So we're going to use a block, of course, if we have more than one statement that we want to execute when a pattern is recognized, or a single statement if we only have one thing to do. And we can have an arbitrary number of these. This section is terminated with a %% token also. And following that, we have the third part of the Lex input file. And that third part is also optional. And it typically consists of, if we do have something there, it's going to be C code, which is simply used as is. So if we have different functions or different things we're going to do in our actions, we can actually put them down in that third part. So those are the basic 3 sections in our Lex input file. Let's look at a really simple example. So here's a file that I named ex1.l. So our Lex files typically have a .l extension on them. In this example, I don't have a first or second part, so they're just blank. So all you see is my action, my pattern action pairs delineated with the double %. So the very first thing I've got here is the string hello space world. So that is a valid regular expression. And it says, look for the token hello space world. And the action here is a printf statement. And it says goodbye in all caps with a new line. So when I process a source file, this pattern will match any string hello space world. And when that's seen, instead of printing out hello space world, it will simply print out the word goodbye. The next pattern is a dot, which basically says match any character. And what I do when I match any other character is just an empty C statement. So I'm essentially ignoring everything else. So the only thing I'm going to do here is look for the words hello space world in my input, and whenever I see it, I'm going to print out goodbye. Everything else I will simply ignore. So once again, the goodbye, the print statement prints out goodbye anytime hello world is encountered, and my second pattern here does basically nothing for any other character that we see in the input. Now, we can run this code by first processing the Lex file. So we're going to feed the source file, ex1.l, to the Lex program, as you see here. When the Lex program runs, if the input is valid, it's going to save the generated scanner or tokenizer in a file called lex.yy.c. So the very next thing you see me doing here is compiling the scanner. Now, the scanner consists of a function called yylex. But in this case, I'm going to use it as is. I'm just going to run that function on my input iteratively until I hit end of file. So I can grab a kind of a prefabricated main out of the Lex library. And you see me linking with a -ll here. So when I do that, it's going to grab the main routine, the default main routine, out of that library. So I can go ahead and run it, which is the next thing I do. I run the scanner here and take input from standard input. So you can see that when I ran this, I typed in the input hello space world, and my scanner obediently printed out goodbye, and then I end-of-filed, and that was it. If I would have typed any other characters here, which I didn't, it would simply ignore them and do nothing with them. So that was a very, very simple example of a scanner that I generated using Lex, and you can see how it's very straightforward to define it, compile it, and run it. So there's lots of very sophisticated regular expressions we can come up with, and I've placed some of them here just to give you some examples. So the string ABC is just going to match the string ABC. I can also use ranges, so here you see in brackets an A-Z followed by a uppercase A-Z, so that expression would recognize any lower or uppercase letter. In the next example, I got a dog dot star cat. This will match any string that has the prefix dog, D-O-G, and ends with the string cat, C-A-T. So the dot star says any other character repeated 0 or more times is acceptable. In the fourth example, I have AB in parentheses followed by a plus sign. This regular expression matches one or more occurrences of the string AB concatenated together. So AB would be acceptable, and any length string, any length combination of AB concatenated with itself. In the next example, I've got a left brace with a caret, A-Z, and all of that followed by a plus. This regular expression matches any string of one or more characters that do not include the lowercase letters A through Z. So the caret at the beginning is negation. It says anything but those characters, and the plus on the end, of course, means one or more. In the last example, I have a plus minus in braces followed by a question mark. The question mark means it's optional. So this is going to give me any string of digits, any string of one or more digits, with an optional prefix of a plus or minus.
So we'll stop here before watching the sample program. I'll put a link in the description of this video that I'm watching. Is by Jonathan Englesma, and the sample program is a bit confusing for me, so I'm going to skip it, and we are directly going to head over to the program that we are going to run in the practical whatever. So let's just directly run into it. So as you can see, first we have our this section. So what is the section called? So this is the first part, whatever we are going to give. So mainly includes libraries. So we'll include library, and if we want to declare some variables, we'll declare it here. So it'll be here, and it ended with this thing, %%. It ended. Now we have written, these are the rules as we know. This ended with a %%, and this is the C file that we are going to, perform these actions upon, grab these actions and perform these upon as said in the video. So we'll start off with private. So these things are like private, public, protected, and this vertical line is like OR. So private or public or protected or system, out, class, these all things that are written, they are basically keywords. So what we'll do is, if we encounter those, okay, so we'll print the thing that we encounter, so %s and keyword, because it's a keyword, that's what we're going to say. And yy.text is basically whatever you match, that is going to be present in yy.text as a string. So you are going to put yy.text in this %s slash and %s, so you're going to put it here. So let's skip to the next one. So next one is a string of, so it's a symbols. So there are invalid symbols. So see, invalid identifier starting with symbol. So you cannot start an identifier with a symbol. So you have these invalid symbols, okay, and then it is coming with one or more number of small a to z, capital A to z, or digits. Okay. Similarly, with this, so as I've written in the comment, so regular expression represents invalid symbols followed by AZ or A to Z or 0 to 9 one or more number of times, because there is a plus and not a star over here. Similarly, like the first one, we have and or and or not. So this is a logical operator. If it sees any of the mention, it is considered as a logical operator. Similarly, for this is if it sees any of these are bitwise. If it sees any of these, it will be considered a relational operator. If it sees this, then it is an assignment operator. Then if it sees // then it's a comment, of course, not followed by a /n. So this thing that we see here is not followed by a /n. So it shouldn't be followed by a /n. Right, and then it can be followed by anything, so we have put star over here. right? So there is the star. So this thing will get a comment and will put the comment, what is the comment, and then this is the comment. It will say, so anything starting with a slash slash and not containing slash n, let's say followed by anything. Yeah. So then we come with this regular expression. So it is 0 to 9, any number of digits, at least one digit. So we have put plus. So one or more number of digits, followed by a dot. A dot is a, like in the program he said, dot is anything. Okay, but if we put slash dot, it's a decimal point. So a decimal point, and then followed by one digit. We have put one digit over here, not any number of digits. So starts with a number, then has this and floating point, middle forwarded by any number of digits. There are not any number of digits. They are probably by a digit, I would say, by a digit, because there is no plus or whatever over here. We can of course put plus here, then it is followed by 0, 1 or more number of digits. That is probably better. So then there is int, char, float. These things, these are data types, as we know, so it will consider it as a data type. It matches with them. Then character constant. A character constant is something like you see over here. So like over here, if you see, it's in quotes. Okay, anything in quotes and is an identifier. So it's either starts with a underscore a, or it starts with like a normal identifier. So like a normal identifier between quotes. So it's a character constant. Okay, and or if it is in these two quotes, so in double quotes, so these things like this sucks, this string, this is a string constant basically. Then if it comes across plus, minus, into, divide, this is an arithmetic operator. If it comes across this bracket, open bracket, close bracket, or close bracket, square bracket, or a curly brace, then it's a bracket. If it is A to Z, so a function is usually, so this is a function. Okay, so it is a function should start with a character and followed by anything and ends with this. So there is this character, one character, whatever. It shouldn't be a number or a symbol or underscore. It should be a character. Then followed by anything, underscore, an A to Z, or capital A to Z, 0 to 9, anything, any number of times, and then followed by a ending this opening and closing brace. So it's a function. You could define it more by putting dot in this function. So like this would also mean, I think so, because like anything could come in between as well. Then there would be an identifier. Identifier is anything that starts with a character. It should start with a character, and or something that starts with the underscore and then character, and then characters or digits any number of times. So that is fine. Then this is probably like this. The examples are given in the comments, so you can see if you're wanting to. So 0 to 9, so invalid identifier starting with a number. So there can be an identifier. This is an identifier expression to, but if it starts with a 0 or a 9, so an identifier is not supposed to start with a digit. So 2020 XYZ is not valid, as it starts with a number. So in C it's not valid. So this is a delimiter. So we'll say it's a delimiter. If we see a dot, just a dot, then it's a separator. It's not dot. If it were without this, then it will be everything. But since we have put it in double quotes, then it's not. So it will be considered as a separator dot. So this is an integer, digits followed by any number of digits. I think it should be 09 plus, because 0 digits is a blank, right? So I have a doubt with that. So multi-line comments is just forward slash and then a star, but then it shouldn't contain any stars, right? Shouldn't contain any stars. This means shouldn't contain any stars. then a star. This star means anything basically, yeah, and then followed by a star, and then followed by this. So it's a multi-line comment. So you can just read it. Forward slash followed by star followed by anything but not star, followed by but not star, followed by a star, and followed by this. And so at the end, so basically something like in the grounds of hi, hello, and we end with this. So this, and in between anything we can. So here we end with our regular expressions, whatever we wanted to do. Then we have int main. So in int main we will have a file pointer. So a file, so it's a file pointer basically, points to a file. So fp, we open a file on a file pointer. So abc.java, I'll show you the thing. It will have the program that we open it in a read mode. So this abc.java, which is here, this will have all the things that we need to check out. Does it work? Does it not work? Does this program work? Where to run it, etc. So why in? So why by n? So in Lex, we give input as fp. So we are giving input as fp, and we do run yy.lex. So yy.lex we have to run. I don't know why, but because it's lex, so you run lex. Yy.wrap, yes. So yy.wrap, it means like a wrap up, right? Wrap up. So if it returns 1, then you wrap up. Otherwise, you return 0 and wait for more input. That is, input isn't exhausted, you can give more input, basically. Basically something like that. So this is it, basically. If this is the output, so you run it by flex lex4.l, right? Then you write gcc lex.yy.c. So after you run this, yeah, so this file is automatically generated, right? So as he says, get saved as lex.yy.c. So this is automatically generated when you write this, and then you /a.out. So then it will print all the things that are there. I don't know why it didn't print all of the stuff, but this was the output given to me by my very good friend. So this is the thing. This is the program for Lex, and I think so that you should explain it this way, so that you will save yourself from your teacher if you're going to give online presentations, or in the practical exam also you might get saved. Okay, so see you, bye bye.